Hi, I'm Mark Wilson, the Engineering Heretic, and today we're going to look at this particular tool, this D-bit grinder, and we're going to look at making just a simple D-bit with a 20-degree relief angle around it, just a square D-bit on some quarter round tool steel. Now, one would argue, why would I want to make something like that? And that's a good question. On a pantograph, I've talked about this before on pantographs, these suit pantographs because it's a single cutting edge. And a single cutting edge is something you're pushing around by hand at high speed. This is something you push around by hand at high speed. You can overcome, it's not difficult to push around a single lip cutting tool. If you have two cutting faces like a slot drill, it becomes twice as hard to push. And of course, if you have an end mill with 4 or more, it becomes even harder. So they don't really suit pantographs. So we normally go with what we call a D-bit. Now, if you're using something in steel, quite often you're actually using carbide. And of course you'd need a diamond wheel for this. We're only grinding high-speed steel at the moment. So there is some need in pantographs for D-bits, but you could make, theoretically, even a cutter like an end mill that would go on a milling machine. You could be stuck for a specific size, a slot or something, not too deep of course, that you would want to cut at a certain width. Well, you could make a D-bit to suit whatever you like and put that in the machine there and cut that and make that. They're a little bit rough and ready on mills, but in the old days, well even today, if you're doing a runner for an injection mold and you need to make a specific runner for track to fill a cavity, you'll need to cut a certain diameter or certain shaped track that you'll have to custom make a D-bit for, because there is no cutters available on the one in the sizes you want or the angles you want. And there's a number of other things you can cut, particularly for injection molds, on a machine like this. And this is why these machines here, despite the fact pantographs are no longer much used, I do have one, because of the injection molding industry, and people want to make their own custom-made tools for whatever they want, rather than having to try and find something off the shelf that looks correct. Well, we're going to make a standard D-bit, and of course we're in quarter round tool steel. And the first thing we need to do is split this in half. Now on this particular head, I have this set up a certain way. I don't have the decal machines have a little dot around the other, a little window and a dot you look through to set this particular tool. Normally, if I'm putting in an existing D-bit, I use my tool setter and I put this onto 0 and then set that there, and that will give me the correct rotation, because I need to be able to rotate 180 degrees on this to a stop to do the relief angle. So if I split this at 180 degrees, that will be vertical like that. Now I need to rotate that around 90 degrees. So if I split that there, then I can now rotate this around to 270, and then put this onto this section here, over that way there. It will then rotate a full 180 degrees with the stops built into the head. And that's precisely what I want to do, the relief angle. Okay, so we're going to put this back to 180 degrees. Now I always leave my grinder set up here. I can actually change these graduations here, but I leave them set up that way because that's the way I use it. So this is just my method here. So the first thing I'm going to do is we're going to start the machine up, and I want to split this particular tool in half. So I'm going to adjust my stop here. Adjust my stop, my little stop here that you can adjust, which will stop firmly. Bring this over in contact and just touch the the tool steel. Now, I need to take successive cuts here, and I don't want to come over the full 1/8 of an inch and just plunge that into the wheel, because what that will do is just round off the wheel and end up with a massive great round wheel there, and that's not what I want. Now, this is going to get slightly hot when I do this, and there's a very big chance that it'll overheat the work. What I want to do is roughen up this wheel to make that a little bit coarser and a little bit rougher there, to just make it cut more rather than rub so much. So we're just going to dress this very, very quickly and roughen up that surface there. Later on, I'm going to double this down again and make it a lot smoother. So we've got our stop set. We've got this on 180 degrees, and we're going to start plunging in, coming out at about 0.1 per time, adjusting this over as we go. It's getting a little bit warm. We'll take a bit of a breather here, and I'll dress this up again just to make sure that that's nice and coarse. And we're having a bit of a breather here because I don't want this thing to get too hot. And we'll go again. Now, you can't use coolant or any sort of water on these heads. Any sort of water will send this thing rusty. Effectively, you have to run everything dry on these machines. Otherwise, they will just gum up, rust up, and destroy your machine. So you've got to do everything dry. And sometimes you have to take a little bit of a breather. Sometimes you can put a little bit of compressed air on there to cool it down a little bit. But generally, you don't need it too much anyway. Right, we're coming reasonably close here. Let's take a bit of a measurement here. We're looking for 3.1 millimeters, which is, because it's quarter tool steel, in the old scale that's 125 thou. We're looking for 3.1 millimeters here. This is a metric machine. I have another, what's that? That's another 1/2 mil at least to go. So little measure. There we go, that. We're very close. I'm going to smooth up this wheel now. Now I've got that a lot smoother. We'll take off the last little bit to make a nice smooth face. .1. So now we've got that split in half. Now when I started this, I started off with this set dead vertical here. Now you need to set that when you're splitting this to make sure our orientation is correct with the tool. Now what I can do is rotate that around 90 degrees to get that horizontal, and I can swing this over here now and put that onto that notch there, and now this is free to rotate a full 180 degrees with a stop. Okay, so now we've got that set up ready to go. I need to put an angle. I need to move this head over whatever relief angle I'm going to put down on this face here. So now this is where I rotate this around. And with splitting, I need to have it vertical. Now I need to rotate this over. You do all your relief angles with this particular scale here. Let's say we want 20 degrees. It's 20 degrees there. Now because we've moved this over, I have to reposition my head because now this is over so far. I run out of travel with the machine. So we're going to lock this one here, unlock the bar here, and bring this over roughly to the right position there, drop that down and lock that in place. So now I unlock this here and there we have, I have to reset my stop because I've moved this. And now what I can do is it will stop, but I'm on a 20 degree angle. I can bring my tool over until I just make contact. Now I've just made contact there. Now you can see a slight little facet there. What we want to do is grind until that facet's gone, but I also have the ability to rotate that and grind the relief all the way around radially as well. So we'll come over a fraction more. And you see there, I just have a little bit more of a facet there. There's a little bit of a flat area there. We want to come over just a fraction more. Fraction more. And there we have our classic D shape with its clearance at 20 degree angle, and we've made it radial around there. Now of course that's not complete yet. I could actually swing this head around and do the bottom angle here, but it's just as easy to take this out of the machine and grind it by hand. Sometimes we even turn around and grind from the front end before they're caught. And we'll grind that, just that last little bit by hand. What does that look like? Not quite. And there we have a classic D-bit. Now I'll bring this up a little bit closer and explain it to you. There we have our classic D-bit shape. And that's just a square one. And that's a classic D-bit. And I'm Mark Wilson, and thanks for watching.